Chapter 1: Measuring Space, Geometry and Accuracy. Subtopic 1: Representing numbers exactly and approximately. We will be looking into bounds and error, percentage error, exponent and standard form. Percentage error is the percentage of difference between estimated value and the actual value in comparison to the actual value and is expressed as a percentage. In other words, the percentage error is the relative error multiplied by 100. Moving on to exponent and standard form. Standard form of decimal numbers is the same as that of whole numbers. Any numbers that can write as a decimal number between 1.0 and 10.0 multiplied by the power of 10 is said to be in standard form. Exponent. Exponent is a quantity representing the power to which a given number or expression is to be raised, usually expressed as a raised symbol beside the number of expression. Bounds and error. For this subtopic, it is very easy. Take a minute to understand what is bounds and error. Moving on to another subtopic, which is under angles and triangle. The ratio of the side of a right angle triangle are called trigonometric ratios. The three most common trigonometric ratios are the sine, cosine, and tangent. These are defined for acute angle A in the right angle triangle below. Take a minute to understand the triangle below. Depression and elevation. Angle of depression is formed when the observer looks down at the yard below the horizontal line, while angle of elevation is formed when the observer looks up the plane above the horizontal line. Bearings. A bearing is an angle measured clockwise from north. The diagram on the left shows a bearing of 127 degrees, and the diagram on the right shows the bearings of the major compass direction. Classification of triangles. Here we will be looking into the types of triangle, by side and by angle. By side, we have equilateral triangle, isosceles triangle, scalene triangle. By angle, we have acute triangle, right triangle, obtuse triangle. Sine rule. In any non-right triangle, the ratio of each side to its opposite angle is the same for all three angles. The cosine rule for angle B can be used to find an angle given three sides using the formula below, where A is the side opposite of angle A. It can also be arranged to solve for the side given two sides and the included angle. Ambiguous case. Ambiguous case is the same as sine rule. When two sides and one angle are known, and the unknown angle is opposite the longer of the two sides, then two triangles are possible. Here is the example of the triangle. Here we will be looking into a detailed example of ambiguous case. Area of triangle. For the diagram show, the area of any triangle ABC can be calculated given two sides and the angle between them. The characteristic of circles. We have the circumference, radius, diameter, chord, segment, point of contact, tangent, arc, angle at major arc, sector, angle at center, angle at circumference at minor arc. Here we'll be discussing these characteristics of circles. Here shows the formula for length of arc and area of sector. Finally, we are at the last subtopic of the chapter, which is three-dimensional geometry. In this subtopic, we will be looking into volume of 3D solids, surface area of a solid, and angle between line and plane. Firstly, what is polyhedron? Polyhedron is a solid made up of polygonal faces connected by edges where the edges meet at a point called vertex. Here you can see the diagram of polyhedron, where you have the face, diagonal, dihedral angle, edge, vertex, polyhedral angle. Volume and surface area of 3D solids. Generally, the formula for volume is space area multiplied by height, and the formula for surface area is the sum of the area of all faces. Here we can see square pyramid, cylinder, sphere, cone, and lastly, rectangular prism. Angle between a line and a plane. Using cosine rule, we can determine the angle between the line and plane, the unknown length. Here are the examples of angle between a line and a plane. That is all from our presentation, Chapter 1. I hope you guys are understand what we are discussing, and if you have any question, please do ask us.